Welcome to this lesson on metallic bonding. Today, we will explore one of the most important types of chemical bonding that occurs in metals. We will understand the Sea of Electrons model, which beautifully explains how metal atoms bond together and why metals have their unique properties. This concept is fundamental to understanding the behavior of metallic elements. Metallic bonding is the electrostatic attraction between positively charged metal ions and a sea of delocalized electrons that move freely throughout the metallic structure. In simpler terms, when metal atoms come together, they form positive ions, and their outer electrons are no longer attached to individual atoms. Instead, these electrons can move freely around all the metal ions, creating a strong attractive force that holds the entire metal structure together. Let us understand how metallic bonds form through a step-by-step process. First, metal atoms lose their valence electrons, which are the electrons in their outermost shell. Second, this loss of electrons transforms the neutral metal atoms into positive metal cations, such as M+, M2+, or M3+, depending on how many electrons they lose. Third, these lost electrons become delocalized and mobile, meaning they are no longer bound to any specific atom. Fourth, this creates a strong electrostatic attraction throughout the entire structure between the positive metal ions and the negatively charged electron cloud. The Sea of Electrons model is a powerful way to visualize metallic bonding. Imagine metal cations as small positive charges arranged in a regular pattern. These cations are surrounded by a mobile sea of delocalized electrons that flow freely throughout the structure, much like water in an ocean. These electrons are not attached to any particular metal ion. Instead, they belong to the entire metallic structure and can move from one place to another. This free movement of electrons is the key to understanding why metals have their characteristic properties. The Sea of Electrons model explains the unique properties of metals. First, electrical conductivity. Metals conduct electricity because the delocalized electrons are free to move and carry electric current throughout the metal. When a voltage is applied, these electrons flow in one direction, creating an electric current. Second, thermal conductivity. Metals are excellent conductors of heat because the mobile electrons can transfer kinetic energy rapidly through the structure. When one part of a metal is heated, the electrons quickly distribute this energy throughout the entire piece of metal. Let us explore two more important properties. First, malleability. Metals can be hammered into thin sheets because metal ions can slide past each other while the electron sea maintains the bonding. The delocalized electrons adjust their positions to keep the structure intact even as the metal is deformed. Second, ductility. Metals can be drawn into wires as layers of metal ions slip over one another without breaking the metallic bonds. The electron sea continues to hold everything together, allowing the metal to change shape without fracturing. Now we will look at two final properties of metals. First, metallic luster. Metals have a shiny appearance because free electrons can absorb and re-emit light. When light strikes the metal surface, the mobile electrons interact with the photons and reflect them back, creating that characteristic shine we see in polished metals. Second, high melting points. Most metals have high melting points because the strong electrostatic forces between the positive metal ions and the electron sea require significant energy to overcome. Breaking these metallic bonds needs a lot of heat. Let us summarize the key concepts we have learned today. Metallic bonding involves delocalized electrons moving freely around positive metal ions, creating a strong electrostatic attraction. The Sea of Electrons model effectively explains all the characteristic properties of metals, including why they conduct electricity and heat, why they can be shaped without breaking, and why they have a shiny appearance. Understanding metallic bonding helps us appreciate why metals are so useful in everyday applications, from electrical wiring to construction materials. Remember, the mobility of electrons is the central feature that makes metals unique among all materials.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.